Today we're going over the Chapter 4 and 5 review. This is to prepare you for the test tomorrow. Chapter 4 and 5 are over proportionality, applying proportionality to geometry and probability. So, question 1 says, which rectangle is similar to a rectangle 5 inches wide and 10 inches long? And we're going to treat that like a fraction, 5/10. And we're going to see which of these answer choices is equal to 5/10. And it will help if you simplify. 5/10 is the same as a half. Now let's check out the answer choices. We have 4/16. And basically what I'm doing is matching the wide to the wide in each of these and the length to the length in each of these. It's like a proportion, but we're seeing which one is equal. 4/16 would simplify to 1/4, which is not the same. And then there's 8/24, which would simplify to 1/3, which is not the same. Then we have 12/16, which can be simplified to 3/4, still not the same. And then 12/24, which you should kind of recognize a half. 12 is half of 24. So these both simplify to 1/2. So D is our answer choice. Number 2 says the two triangles are similar. Use a proportion to find the length of the sides marked X. Okay, you can do this without setting up a proportion, but since it says to use a proportion, let's practice doing that. I'm going to take these numbers from the little shape and put them with their matching number on the big shape. So like 2 matches to 12, and 3 matches to 18, and 4 goes with X. If you'll match them up like that, that becomes the fractions that go in your proportion. And I'm going to use the 2 that I circled. You can use any of those, but I'm going to use the 2 smaller numbers and the X. So we have 12 and 2, and then 12 is on the outside because it's the big triangle, so that needs to match to X. And 4 is on the inside because it goes with the little triangle, so it matches with the 2. Then we look for a relationship. What would I do to 2 to get to 4? Times 2. So if I do that on top, I get 24. So X is equal to 24. Number 3. The scale drawing shows a theater. What is the length of the longer side of the actual lot? And again, we can use a proportion to solve this. Our scale is 1 centimeter to 20 feet. And it says the longer side, so the longer side would be that one, 5.2 centimeters. And again, I want to match up the centimeters with the other centimeters. That means this is going to go on top. And I'm trying to solve for the actual. Well, what would I do to 1 to get to 5.2? I would multiply by 5.2. So I need to do that on the bottom. 5.2 times 20. And when you multiply by a number ending in 0, we just put a 0 down and we're done with that. Then we want to multiply by the 2. 2 times 2 is 4. 2 times 5 is 10. We have 1 decimal space in the problem, so I want to move it 1 decimal space in the answer. That makes 104. So X equals 104 feet. When you enter it, you can just put 104 feet. Number 4. Which rectangle is similar to a rectangle with 3 inches wide and 9 inches long. So that's kind of like what we did with number 1. We're going to set up some proportions, but let's just simplify that fraction first. 3/9 simplifies to, if you divide both of those numbers by 3, it simplifies to 1/3. So let's see which of these answer choices simplifies to 1/3. 3/10 does not simplify anymore. It would just be 3/10, which is not the same as 1/3. If you need to change it to a decimal, you can. This would be the repeating 3, which is not the same as 0.3. Then we have 20 over 32. And we can simplify both of those by 4. And we get 5/8, which is not the same. Then we have 24 and 32, which can both be simplified by 8. 24 divided by 8 is 3, and 32 divided by 8 is 4. 3/4 is not the same as 1/3. Next one, 6 and 18. Both of those numbers can be simplified by 6. 6 divided by 6 is 1. 18 divided by 6 is 3. And that does match. So my answer is J. Number 5 is similar to number 1 and number 4. It says a rectangle 9 inches wide is triple that long. Which of these describes a similar rectangle? So 9, triple means times 3. And 9 times 3 would make 27. So the fraction would be 9/27. 9 inches wide by 27 long. Okay, so which of these could I multiply by 3 and get the other number? Or you could simplify the fractions and see which one comes out the same. I'm going to multiply by 3 because it said triple. So 3 times 3 would make 9. 9 times 3 does not make 12. 12 times 3 does not make 18. 15 times 3 does not make 30. So the answer is A. Number 6. In this figure, triangle SJC is similar to triangle ANC. And SJ equals 16, and AN equals 4, and CA equals 3. What is the length of AS? So this triangle SJC and this triangle ANC are similar. Sometimes we have a hard time seeing them when they're stacked on top of each other like that. So I recommend redrawing the triangles. So this will be the big triangle, S and a C and a J. And it says from S to J is 16. And then I'm going to put the matching little triangle. So A goes with S, so I'm going to put A inside. N goes with J, so I'm going to put that inside. And then C is still C. It says AN is 4. So A to N is 4. C to A is 3. And we're supposed to figure out AS. Well, AS is just part of this right here. So we're going to figure out what this part is. We're going to set up our proportions using these fractions. So 16 came from the big triangle and 4 comes from the little one. X is from the big triangle and 3 is from the little one. Is there a relationship? I can't do anything to 4 to make it a 3. So let's try to simplify. I can simplify by 4. So 16 divided by 4 is 4. And 4 divided by 4 is 1. Now there's a relationship. What would I do to 1 to get to 3? Times 3. So if I do that on top, the x equals 12. So this big long side is 12. And they said that this part was 3. So what does that leave for this part? I know in our drawing it looks like half, but if I put 3 down here and 3 up here, that would make 6, not 12. So what could I add to 3 to make 12? Nine. If I put 9 right there, then 9 plus 3 makes 12. So AS equals 9. Number 7. Colton created a scale drawing of the school in his art class. In the scale drawing, the length of the cafeteria is 4 inches. The length of the actual cafeteria is 160 feet. What scale did Colton use to create the scale drawing of the stadium? I think that's supposed to be cafeteria. So we had 4 inches to 160 feet. That was the scale they gave us. And we want to figure out if it's the scale for the drawing, we want to change the inch to 1. So what would I have to do to 4 to change it to 1? Divide by 4. So if I do that on bottom, I'll find out what 1 inch equals. So 160 divided by 4 is 40. So the scale for the drawing is 1 inch represents 40 feet. Number 8. Circle R has a circumference of 25.12 feet. Circle R has a diameter of 8 feet. What expression best represents the value of pi? Okay, well, it's talking about circumference, and the formula for circumference is 2 times pi times radius. Or it could be pi times diameter. So they have told us that the diameter is 8. And I'm just going to leave the symbol pi there. And that's going to equal the circumference, which they told us was 25.12. What this means is that they want us to get the pi symbol by itself. So to get pi alone, this is pi times 8. We do the opposite. So if I do the opposite of multiplying by 8, I will be dividing by 8. That makes the 8's cancel, and now pi is by himself. And the only thing on the other side is 25.12 over 8. And when they said write an expression, this is the expression. You don't have to work it out. Number 9. Wyatt rolled a number cube that had sides labeled 1 to 6. What is the probability that he rolled a 1, 2, or 6? Well, a number cube is a dice, and the dice has sides with dots that have 1, 2, 3, 4, 5, and 6. So there's 1, there's 2, and there's 6. The chance of getting those would be 3, because there's 3 numbers that I circled, out of how many possibilities? 6. 3 out of 6. And we need to simplify that. And we get 1/2. So the probability of him rolling a 1, 2, or 6 is 1/2. Number 10, Logan flips a coin 5 times. What is the probability that she flips tails all 5 times? Okay, well, the first time that she flips the coin, what's the chance of her getting tails? Well, there's 1 out of 2 sides. So the first time, 1/2 chance. The second time, what's the chance of her getting tails again? Well, it's still 1 out of 2 because there's 1 tail out of 2 sides. Then the third time, it's still 1 out of 2. And then the fourth time is still 1 out of 2. And then the fifth time, she still has a 1 out of 2 chance of getting a tail. Then this is a combination, so we're going to multiply all of these possibilities to see what's the chance that it'll happen all 5 times. Well, 1 times 1 times 1 times 1 times 1 is 1. And 2 times 2 is 4. And 2 times 2 again is 4. And 4 times 4 makes 16. And 16 times 2 would be 32. So the chance of Logan getting tails 5 times in a row is 1 out of 32. Not a very good chance. Number 11. The probability that Jessica receives an A on her graded papers is 12%. If she receives 86 grades in a grading period, about how many of them can she expect to be an A? Well, you could set up a proportion, or you could just remember that every time there's a percent sign, well, just about every time there's a percent sign, change it to a decimal and multiply. So 86 times, move the decimal 2 spaces, so that would be 0.12, and multiply it out. 2 times 6 is 12. Carry the 1. 2 times 8 is 16, plus 1 makes 17. Done with that 2. 1 times 6 is 6. 1 times 8 is 8, and then you add. There's 2 spaces behind the decimal, so I need 2 spaces behind the decimal in my answer. The decimal goes right there. So about how many can she expect to be an A? About 10, because we want to round it to the whole number. Number 12. Jade made a 3-digit code. The first digit is even. How many possible codes can she choose from? Well, digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are the digits. How many of those are even? I circled 5, so 5 are even. So there's 5 possible digits to choose from on the first digit. But she's going to make a 3-digit code. So how many digits can she choose from on the second digit? She could choose from all of them, so there's 10. And then the last digit, she can choose from any of the options, so that's 10 again. And then this is a combination, so we multiply. 5 times 10 makes 50. 50 times 10 makes 500. 500 possibilities to choose from. Number 13, Sam can choose between 5 pairs of pants and 8 shirts. How many different outcomes are in the sample space? Well, we could make a list, or we could do just like we've done on the last one. There's 5 options for pants times 8 options for shirts. That makes 40. Anytime you have a combination of things, we just multiply. Number 14, a bulletin board has 5 blue thumbtacks, 2 green thumbtacks, 8 red thumbtacks, and 9 yellow thumbtacks. If a thumbtack is selected at random, which color is most likely to be chosen? Well, which one has the most? 9 is the most. So the one that is most likely to be chosen is yellow. Number 15. The experimental probability that Caden will win a game is 4/5. If he plays the game 55 times, how many times can he be expected to win? Okay, so we're making a prediction. We have 4 out of 5. The 5 is the total. And if my new total is going to be 55, what would I need to do to 5 to get to 55? Times 11. So if I do that on top, Caden will expect to win 44 times. So 44 is your answer. Sorry, 16. A bag contained 8 red crayons, 12 green crayons, and 5 blue crayons. If Bree draws a crayon from the bag, what is the probability in decimal form that it is a blue crayon? Well, there's 5 out of, what's my total? I'm going to have to add all of them up. 8 plus 12 plus 5. That makes 25. So 5 out of 25 is her chance of getting a blue crayon, but we need to change that to decimal. And if you'll remember, there's some magic denominators that I can change to a 100. This is one of them. What could I do to 25 to change it to 100? Times 4. So if I do that on top, I get 20. And 20/100ths is just decimal 20. And if you can't remember about the special denominators that turn into 100, you can always divide to find the decimal. And you'd still get 0.2 or 0.20. Number 17. Answer the questions below by writing 2 or 4 complete sentences in the spaces provided. Darla has a bag with 4 green, 7 orange, and 9 blue marbles. She randomly selects one marble, does not replace it, then selects another marble. Explain how to find the probability of Darla selecting 2 blue marbles. Well, the first thing we need is a total. And how do we get the total? We add all the marbles. So that's the first thing I'm going to write. Add all the marbles to find a total. The next thing we need to do is find how many blue marbles, and that will be the new numerator. So the probability of picking a blue marble the first time, because it's going to be different the second time, the first time is 9 out of, and can we add those up real quick? 4 plus 7 plus 9. That makes 20. So the probability of picking a blue marble the first time is 9 out of 20. Or 9/20. Now the next time she's not going to replace it, so we have to subtract 1. So since she is not replacing the blue marble, we must subtract 1. Now what do we subtract it from? The numerator and the denominator. Subtract it from both of those. This makes the probability of the second marble being blue 8 out of 19. Then we take those two fractions and multiply. So finally, multiply both fractions. Add all the marbles to find a total. The probability of picking a blue marble the first time is 9 out of 20, or 9/20. Since she is not replacing blue marble, we must subtract 1. This makes the probability of the second marble being blue 8 out of 19. Finally, multiply both fractions. You don't even have to tell me an answer. That's just, you have to explain how. Number 18. Answer the question below by writing 2 to 4 complete sentences using the words circumference, diameter, and pi. Bart used a string to measure the distance around a tire. He did not have enough string to go all the way around. How can he calculate the distance? Okay, distance around something circled is circumference. So he's trying to measure the circumference. And the formula for circumference is 2 times pi times radius, or pi times diameter. So if he can't make it all the way around the circle, what would be a shorter distance that he could measure and calculate the circumference? What if he measured the diameter? The diameter would be shorter, and then he could multiply that times pi and figure out the circumference. So that's what I'm going to write about. How can he calculate the distance? He could measure across the middle of the tire and find the diameter. Then multiply times pi to find the circumference. And that's all. 2 sentences, that's all it took. Now for the pre-AP section of the Chapter 4 and 5 review. Figure A, B, C, D, E is similar to figure V, W, Y, Z, X. Which proportion must be true? So if you'll notice, the two shapes don't exactly line up. They're kind of turned different directions. You can use the markings in the corners by the angles. So like angle E has one line, that's going to go with angle X, which also has one line. But then there's two right angles, and if you're not very good at manipulating the shapes in your mind, it might be kind of hard to line those up. An easy way is to look at the letters themselves. In the problem, they have to write the letters in the same order. So A matches with V, and B matches with W, and Y matches with C, and D matches with Z, and X, of course, goes with E. So now that I've matched them all up, I can see which proportion goes together. The first one says AE goes with XY. No, it should go with VX. So that one can't be it. The next one says AB goes with VW. That is correct. It also says that CD goes with YZ. That is correct. Those do match up. And it also, AB comes from the big shape, and CD also comes from the big shape, and YZ went from the little, and VW also went from the little. So not only do the letters have to match each other, but big has to be on top on both sides, or little has to be on top, or vice versa. You have to have the sizes match up as well. So that one might be correct. Let's check the others. So the next one says BC. BC matches with XZ. That's not right. BC should go with WY. So that one's not right. The last one says DE, which is over here. DE goes with ZX, which is right. And then YZ matches with CD, which is also right. Now DE comes from the big shape, and YZ comes from the little shape, and ZX comes from the little shape, and CD comes from the big shape. So big did not go with big, and little did not go with little, so that's not correct. And they will try to trick you like that, so you have to be careful. So the correct answer is G. Next question. Triangle ABC is a sloped triangle for the line shown in the graph. What are the coordinates of another sloped triangle for the line given that the triangle shares a vertex with the triangle ABC? Okay, so it's got to be a right triangle. Remember we talked about this. It's got to be a right triangle. So you're going to have to plot these points onto the graph. So the first one is 0, -2. So I go over 0 and down to -2 and put a dot. Then go over 4, -2. So 1, 2, 3, 4, -2 and put another dot. And then if I connect that to A, that does not make a right triangle. To make a right triangle, it would have to go straight up. It did not. So it can't be that one because it's not a right triangle. Next one. Go over 0, down -2. Then go over 2 to the right and down -2. And then connect to B. Does that make a right triangle? Yes. And it's using the slope of the line. So that might be our answer. Let's check the others. Okay, again, we go to 0, -2. and 2, negative 2, and then it connects to C. That does not make a right triangle. It doesn't really make a triangle if I tried to connect it to the slope. The last one, 0, negative 2, and then go to the right 1 and down 1, and then connect to B. So again, that doesn't make a right triangle. So the answer is B. Next question says, describe pi. That means give the definition. And the definition for pi is the ratio of the circumference of a circle to its diameter. The ratio of the circumference to the diameter of a circle. Next question. Bob walked from the middle school to Bobby's Tires and then to Walmart. The diagram shows the top view of the location of these 3 places and their distance from each other. So I'm going to guess M is supposed to be middle school, B would be Bobby's Tires, and W would be Walmart. What measurement is closest to the shortest distance from the middle school to Walmart? So they're asking for what would be that distance. The shortest distance is a straight line. So he went 3 miles plus 4 miles, and we want to know this one. That would be that A squared plus B squared equals C squared. So that's my C. And remember, you're not allowed to use a calculator, so the numbers will probably be easy. 3 squared would be 9, plus 4 squared would be 16. 9 plus 16 makes 25. And then we find the square root, and the square root of 25 is 5. So C, or the distance, would be 5 miles. Last question. What is the slope of the line? Well, remember that's the change of y over the change of x. And you can pick any dot that you want. There's 2 already on there, but if you see another one that you like better, you just go right ahead and use it. So we need to find 2 y's and 2 x's. I'm going to just use the dots they gave us. So 20 minus 10, and the x that goes with 20 is 2, and the x that goes with 10 is 1. 20 minus 10 is 10. 2 minus 1 is 1. So the slope is 10.